Good evening, good evening. Thank you. Welcome all to my class. We stopped at a point where we had these components last time. I showed you. You can follow, like our page, and continue to subscribe, watch my content. You can share and make good use of my content. So guys, today we are going to have to learn about these gadgets here. Last time I demonstrated how to connect a contactor, and we even had some light. We had some light for demonstration. So we said we need to switch our coil here, and then we need to supply power that should now come out to our load. We used this bulb holder for simulation to replace the motor, so I can put some light and we can see how things go. Just as a reminder, we are going to demonstrate once more, then move to how we connect this other piece here. Follow my page, like, subscribe, please tap the screen, share, go to WhatsApp, Facebook, and share everywhere to my socials and set gifts. Here we are, and we are gonna start our class now. So basically what I have here is a 240 volts bulb. We are going to connect it here to this outlet. Then you can see if we connect our 240 volts on this supply here, we will actually be powering our coil and at the same time supply voltage to this terminals so that it can have output here. Please like page, share with your friends, let them know we are having this live class, and it's gonna be nice. If you are here and you would like to concentrate and have deep knowledge on this, I've posted my videos on YouTube. I'll find our 240 volt supply and we see how this performs. So what I have here is a cable. It's a cable carrying 240 volts. I will test it with my multimeter, so you'll be able to see it's 240 volts. So remember to tune your meter to AC voltage. That is this point here, 750 VAC. Remember we expect about 240 to 250 volts, so 750 VAC is fine. Please join my page, guys. I'm waiting for you so that we can proceed together. I'm just giving a reminder of what we did last time. So if we have this 240 volts outlet, we can confirm it from our meter here. So we put one probe there and the other probe right there. You can see we have 243 volts. That's a good voltage range. So if we have our setup here, I hope you can see my wires clearly. So this is where I put my input. Around here. Then I'll try to see if we have a bulb light. Remember we said this switch is for controlling the coil. Because we use it to control the contactor, we cannot control the power directly through the switch because the power is too high. So we use the switch to control the coil, and then the coil pulls the contactor in. So if I put my voltage here, my switch is off. You can see guys, my power is now in. Like this. So when I switch this switch on, the contactor and the light should go on. Let's see. You see, the contactor is in, and when I switch off, it goes off, all of it. On, off. So that is how we control the motor. Assume the motor is now the bulb itself. So when I switch on the coil using the coil, I'll be able to power the motor like this. Like this. So that is what we were able to do last time. So today let's see how we are going to connect this other type here. So to start with, you can see this is a manual operated contactor. So, and we have a regulation for current. This knob here, it's for regulating current. I don't know if you can see it very well, like this. This is inbuilt or onboard mounted overload sensor or thermal overload that helps trip this switch when it's on. When there is a fault, this thing automatically trips like that. So I'm going to show you how it connects. So stay tuned, log in. You can hang on guys, and we are gonna see how this goes on. So basically what I need to do is disconnect these connections and transfer them to this contactor. You can also try to face your question, your views, your recommendations on this channel, also on Facebook, on YouTube, TikTok, everywhere you can comment, share, like, and subscribe. We are waiting for you guys. So I can grab my screwdriver and see how this is connected. So we can start by disconnecting our main power here, and then our load. Then see guys, here is our power connection for the coil for the first contactor, but remember this is manually operated. We don't have a coil to connect or to energize so that we can activate the contactor or engage the contactor. Remember, this is the most widely used type of control in wide industries or heavy manufacturing. So where motors are applied, we always have this kind of gadgets. So stay tuned, don't miss out, because you will face them in the field. So we can take away this one. We have seen where we connect the coil, the voltage we use, how we couple this one, and now let's shift to the other type or the other model. This is manually operated. You have a push button on board for start, black, then red for stop. So if any case of emergency occurs, it will just do itself automatically, but you need actually to press it like this in order to start, and like this to stop. So let's see how it's connected, guys. Thank you, Tony Jenny, for joining. Thank you guys. Share, let everyone know that we are live. It's gonna be nice. It's gonna be nice. It's gonna be nice. Please share. Thank you Saidi Mohamoji for joining. Tony Jr., thank you very much. It's gonna be a good class. Invite your friends who are interested also. We share and let everyone know that we are live now. Thank you Mosa for joining. Yeah, thank you. You are a good family to me. I can't ignore you. So what we have just said, we reviewed and just reviewed how we did about this, the connection and the actuation and how it's used for motor controls. Thank you Lacoste for joining in. Now what I'm doing here guys is that I'm trying to demonstrate how we connect this one. I hope you can see me. Thank you Yusuf. I think you have a very big code, but welcome all. I think you can see the gadget now perfectly. Remember we started by numbering these gadgets. This is terminal 1, this is terminal 2, terminal 3, terminal 4, terminal 5, terminal 6. Why we don't have terminal A1 and A2 is because in this one we don't need a coil to actuate it. Thank you Kevo, thank you Mal Macran for joining in. Thank you for joining in everyone. What we do here is just that we follow the same procedure for termination as we did in the last one. Remember for this one, we had our main terminals entering from the top and coming out from the bottom. The same thing we do here. So I will connect my load from the bottom and my supply from the main. Thank you Top Boy Vic for joining. Shamon, thank you SP13. Everyone who has joined in, please share, like, tap. Griff Kiki, please engage those gifts, let them fly. So we said basically what we do first of all is to check and measure if our contacts are okay. Remember, during this step, make sure the power is off and is not connected. Thank you Barack Obama for joining in. So when I put this gadget on like this, these points should be interconnected. Thank you Freddy for joining in. Please fly those likes. Ken Edukon, thank you. It's gonna be a good class. Engineers, invite your engineers, your fellow engineers. So we are gonna adjust our meter to resistance mode. Here we are, like this. This guys we said is not called a 1, it's high. In terms of resistance it's called high or is considered high. So when we point our probes together, it should give us a buzzer. You see guys, so this means continuity or lowest resistance. That means high resistance. So thank you Frank, thank you Funded, thank you Steve, thank you Mikey, everyone, thank you very much. So when I test my points here, you can actually see they are now connected like this. You see, now remember these are major terminals and these are what we use when we are putting power into the motors. So basically this is an old piece I had here, but I think it is gonna work with these two poles because the third pole I think it's giving a hard resistance, but I think it's because of the screwing. Thank you everyone who is joining in. Thank you Culture, Yaku, Nairobi, Vincent, Van, Jimmy, Rashido, Smiley, everyone please, thank you for joining in. Case closed, thank you Frank, thank you, welcome all. Tap on that screen to give it a like. A diamond, and let's see what's going on here. We said we confirm using our continuity meter, so we need to measure before we connect it to power to make sure every connection is connected. So thank you guys for giving me your time. Let's explain this and see what happens here. Remember we said when it's on, our contacts should also be on. We can see that. You can see that this is continuity, so it means if there was power it would be connected. But when I press this thing on off like this, It means now these terminals are not connected anymore. It won't be connected anymore, so it should just be good. When this switch is on, it should connect. Thank you Pepe Jonte, thank you Teresa, thank you Kemutai, thank you Avante, everyone who has joined in, thank you. Remember, you can also check out on my page, YouTube, Facebook, subscribe, also like, comment, leave your recommendations there. Please let us make a good family, a bigger family. Remember, this is a free of charge class, so don't forget to invite your friends. So after now measuring like this, guys, we have seen our lines are okay. So what we want is first to connect our load. Remember, always start with the load before you connect the supply. So assuming this is our motor and this is our switch here, I'll come and connect to any of these, provided I'll also consider the lines coming in. So if I connect my load on terminals 2 and 4, I need to connect my supply on terminals 1 and 3. So you can see how it's actually done, guys. Thank you. Please like that video. Please, if you like my content, let me know, just for motivation. Tap on that screen to just wave a sign. You remember you said never hurry when doing anything electrical. This is what we call a good connection. You don't have strands of wire hanging outside, but you also holding the copper where it should be held. Don't hold the insulation instead of the copper conductor. That makes a loose connection or disconnection. So now, having connected our load, we will have our supply from at point 1 and point 3. So I can have another set of cable here. This is what we used in the earlier connections, so it's fine. So I'll put my power on terminals 1 and 3. Thank you everyone. Amin, Daiman, Delo Cruz, CL7 Fan, Nancy Minor. Thank you everyone. Thank you everyone for joining in. So remember, this is how you'd practically connect a motor if an industry wanted them to solve wanted you to solve the problem for them. You must undertake these precautions and follow these procedures so that you don't cause any damage or be at any risk when handling this power. Remember, before connecting your power, your connection or setup must be always fine, so that to be sure, you can also take your meter again, check for any short circuit. This is done by pointing your probes at each of the wires like this. So no short circuit. If there was short circuit, it would sound like this. So when I connect my power, now everything should be fine, because you can see the setup is clean. No a lot of wires as compared to the first connection. So having my 240 here, remember we said always start with the system off. So I can plug my 240 volts. Remember, you have only one connection because we don't want any power for coil, because in this one we don't have a activation coil. With the power connected like this, guys, now we can try switching on our switch and see if our bulb will turn on. So basically, I don't need to energize any coil. All I need to do is switch this button and power should flow here. And let's see. You see, guys, It's now on because now I have actuated the contactor. If I want to switch it off, I just press the red button and that is it. So here is the good point, guys. Thank you for giving me a like. Everyone, please feel comfortable to just tap that screen to just support my content, and I'll be dedicated to give you more and better. So you have just seen that if I press this power, the bulb goes on. Thank you guys. If I press it off, the bulb goes off. Thank you for tapping and flying the likes, please. Thank you very much. I love you guys all. Thank you, Ruth, for joining. Collins, everyone, please, thank you. I appreciate this. I'll be dedicated to give you the knowledge you deserve because you guys are a good family. So I'm illustrating my thing here. Remember, we had another type of contactor last time, and here it is. This one, we need to energize this for it to work and power our load here. That is, in this case, the bulb, and in industry level, the motor. Thank you, everyone. Jojo, Annie, Collins, everyone, thank you for tapping. Like, please tap on that screen. Continue tapping. Thank you. I feel motivated, guys. So what I'm saying is, this one we need to switch manually like this. And now that brings us to the point where I was arguing that, tell me if this is a contactor or is it a circuit breaker, as many call it the motor circuit breaker. So guys, to me, this is a contactor because one, it has this overload adjustment knob. So in case of anything, it will trip. So if I brought this contactor here and then I added this overload over here, because they are connected in such a way, like this will function the same way as this one's could. So if I just press this one on and anything happens to this load, this thing will automatically trip depending on the amount of current you have set for it to trip in case of any failure. So please let me know if I can repeat any point. Continue liking, please, guys. Hit that screen. You are so nice guys to me. I really like that. This is a good motivation. I am here for you. Remember, these are live classes that come to you free of charge, but very important, practical, and practically problem solving. Remember, you can share with your friends. Let them know that we are having live classes. Those who are interested in engineering, here is the place to be. Yours truly here will be bringing you practicals, demonstrations, experiments, and more. So come in, join in. Please hit that like, please, guys. Tap on that screen. I really feel motivated by you guys. At the same time, you can see my setup. It's working perfectly. Another thing, guys, you need to know, if you feel unsafe using this auxiliary alone, you can actually add this. If you wanted to add this, you can come, disconnect your load from the bottom here. You can put your screws out. Thank you, Pesh. Thank you, Vincent. Thank you, Sylvia. Thank you, everyone who has joined in. Thank you, Flavor. Thank you, everyone who has joined in. I really love that. You can come and engage an extra overload relay over here. So like this, guys. You can see it fits perfectly, just as it fits. Just as it fits on the other contactor. You can see we have it there. Make sure you loosen all your screws before inserting the pin, so that you can just be sure that your pins are intact and are locked in place like this. Thank you. Oh gosh. Thank you, Native. Thank you, Frida. Thank you, Nature Boy. Thank you, Christine. Thank you, Rob Doctor. Everyone, you are free to join because this is a class of everyone. You can see now I have my overload locked, so I can use these two just to connect my power and be double safe. So if I take my multimeter here and switch this circuit on, remember it should not be in power during this test. And then I point my probe there. Remember this line should be continuous like this. This line should be continuous like this. And the left line should be continuous all through. So if this one is reset to default, I should get continuity right from this line up to the down point. Oh God. Unfortunately, I lose my lines there, but actually you can see my middle line is sensing. You can also see my first line is active. I don't know why this one is not in. It's there, it's in. You can actually see my terminals are connected. So like for that. So guys, you can see now we have double protection. But if anything happens, now you can be sure you can be safeguarded by this. Remember I showed you how this operates. You can reset it when you want in case of fault. You can just open this screen and reset. Make sure there is a switch to test. It's on auto mode, so that when you reset on this, you reset everything. This is the knob I'm talking about. There is a switch for manual and auto reset, so you can see. The reason why I'm saying I argue this to be a contactor, it's also rated in kilowatts somewhere, of which that means it should be running something like a motor at the source rated in amperes at 3-phase voltage. These are the specifications used in labeling or designating values for a contactor. So I prefer calling it a contactor rather than a motor circuit breaker. So if I come here and connect my load, it will look something like this. Continue liking, guys, continue liking. This is very nice class for everyone. So after now connecting this setup here, guys, we can take back our 240 volt supply. You can see this is not hidden or does not have anything hidden anywhere. It's a clean setup. Then we can insert our power here. Remember we said always put it when your circuit is off. Make sure the circuit is off before you put your power here to avoid any kind of unexpected ruptures or something. So when I pull this switch on, you can see it's now connecting my power from the top, that is the supply, to now my motor, that is the bulb for this case. So you can see, guys, my illustration is fine. So if I connected the motor here, I would use it because my power would flow. Now what I want to show you guys is why I said these 2 points are very important in our control circuit, because these two are normally closed and these two are the ones that switch off power practically when a fault occurs. Remember the mechanism for overload detection is inside, but these are the terminals that actually break the circuit. Terminal number 96, no, terminal number 96 and 95, yes. So this is normally closed. So if I unplug our power and literally come and measure these points, I think we have 94, 95. these 2 points here, I don't know why they are off, but they should give us a normally closed circuit, so that when there is a problem, let me try setting it, see if I have a connection. I still don't have the connection, so I think my terminals are broken or my circuit is broken from inside, so no big deal. But these 2 terminals are actually the ones responsible for cutting off the power to the control system, so that we can deactivate this kind of contactor, you see. But you can also use it to have an auxiliary power cutoff or indicator light when the circuit has tripped for this contactor. Remember, you cannot actually control this contactor using these terminals, because this does not use a coil to engage. So even if there is a fault, this inbuilt or this surface, or not surface mounted, but onboard overload relay will detect and trip this switch automatically. You see, remember, when only in on position we have it there, so in case of any mishappening in the load, the red one will enter and the black one jump off, like this. So that is why we use these gadgets in motor control, because remember, motors are continuous running machines and they need protection so that they can immediately stop in case of unprecedented or unseen circumstances, so we don't cause more damage when the motor runs maybe under a fault. Remember, we also have extra gadgets that we use for safety, that is like the phase failure relay. If we have one phase going off, it will switch off the whole control circuit. But remember that during this time we have to use this kind of contactor. So after showing you how it's done, guys, you can give me those likes. Let me see where you didn't get it right. Give me those likes, guys, and let me know where I can actually repeat. If you like what I have just taught, let me know. If you want me to actually repeat a lesson that you did not actually get comfortable with, I'm here to do that. Follow all my socials in Facebook, Hood Engineering Solutions. See my reels there, see my YouTube channel. You can actually learn more and more from there. So another thing I wanted to show you guys just a little bit. This is another gadget. Before I tell you what it's called or how it's named or how it's even labeled, please give me a like for this. Thank you, Pauline Gure. Thank you, Cadet. Is it Cadet or something? I'll show you how this one is used and why we use it. Remember, this is not used on its own. This one is called an auxiliary contact that is actually used together with this kind of contactor. It's called a hook auxiliary contact or contact block. This one has these terminals. 2 of them are closed and 2 of them are opened. That is normally opened and normally closed. These ones are used during forward reverse run of the motor to make sure the faces do not collide. This is, it has a hook and it's inserted on this groove. So you can see it's male and female. So it enters from the top like this, then you slide it in. Actually it has this lock, so you slide it in like this and release the lock. This lock is responsible for holding it in position. So what happens, guys, you can see it has this thing and you can see it going in and out. So this contactor also has something to try, so that when it's activating, you can actually see it's pulling the auxiliary contact in or out. So these ones are used to avoid during a forward run, remember we use the sequence red, white, blue. That means the original sequence of three-phase power. When we go to reverse, we interchange any of these two powers. Now the biggest mistake could be when these two powers collide. Like when you are changing from the red input to blue input and the blue input to yellow input, it means if they happen to collide, then there is a very big short circuit, and that means you have damaged your contactors. So what we do is something called interlocking. Interlocking means until one has completely turned off, that is when the other one will turn on. So taking our meter here, and thank you everyone for joining. Thank you very much. Give me those likes, guys. They are not yet enough. I really like to see you. Thank you, Lea Moreiti. Thank you, Kade. Thank you, Githai. Thank you, Miscellaneous. Thank you, Corino, or something early. So if I take my meter here, I can be able actually to test these blocks and actually see which one might be open or closed. So by now I can't trace any normally closed block, but I think it's because my gadget has been sitting for too long. Maybe there is rust or something, but actually we have two normally closed contacts and two normally open contacts. What happens, those that are closed, when this contactor enters like this, they become open, and those that were open become closed. So when we say normally closed, it means during normal conditions when the power is off, the closed ones are closed. That is, they are continuous or connected. Those that are open, they are normally open because they are not connected. When the power is applied, the reverse happens. Those that are normally open, they become closed. Those that are closed, they become open. So basically these are some of the auxiliary gadgets we use with these things. And then I told you we have other things like the push buttons and emergency switches. So I'll also try to find those pieces, illustrate to you and see how they work. Remember, I also told you despite using this switch in my illustration, this contactor needs just a single press button, then it should hold on the power by its own. That is when we apply coils number 13 and 14 in parallel with power on switch, the green switch, that is polarity number 3 and 4. So with that, guys, I think it's good time. Thank you for your time. And we have actually our daily question. I'll be going and posting my question on all social medias. So last time I had asked people to give me explanation of what is electricity, and yes, they did, but I gave the answer. You can also refer to my channels and see the answers. So thank you. Go to my pages, like, follow, subscribe, comment. Everyone who has joined in, followed me, thank you for your like, guys. I think this is the best family to ever lead or give my experience to. Remember, we are doing this as a free and a clear practical course, so please feel free to join. I'll be posting to you when I'll be having my live classes, so be ready, be updated, go there, follow my pages and see. So today I will give you a bonus about my question. I have a small gadget over here. This gadget, we have finished about the motor controls. This gadget, it's an electrical or electronic gadget, but it's widely used in the electrical field. Just to give you a hint, it needs a DC battery to operate. Tell me what this is and tell me why you think it is, what it is, what you say it is. You can check it clearly. You can check it. If you think you know what it is, let me know. A hint, it must be used with a battery. So let me know. It has input, output, but it has to be fed with a battery voltage for it to operate. Let me know what it is. I will also be posting it in my socials and let people tell me what you think it is. Guys, thank you very much for joining me. I really appreciate your time. This is not taken for granted, and please let me have you follow me on my pages like Genuinely. Let's meet on Facebook, YouTube. Very nice tutorials there, and DIY projects. If you have your sockets disturbing you every time, your plugs every time burning up, your bulbs can't even work, you are always tense to live in your house because of power problems, please follow my page that you will get enough knowledge of how you can maneuver around all these challenges, because you don't need a technician and pay them thousands of shillings or hundreds of dollars to check something you can actually learn from here for free anytime and do it for yourself. Please consider that as your advantage, and thank you everyone for giving me your time. Your time is precious. You really deserve a reward, and my reward is just staying dedicated, giving you quality content. So let's meet in social handles. I will also post this video for everyone who has been late for the class. So thank you guys. Like my page on Facebook, Hood Engineering Solutions, on YouTube. Comment, share, like, subscribe, Hood Engineering Solutions. Here on TikTok, follow Hood Engineering Solutions. Thank you. Have a good night.